people seem to be quite entertained by my live demos, so I stick to that.
Okay, all right. So nothing like a demo gremlin to keep you on your toes.
It does, right? It does. It keeps you on your toes. That's why I volunteer for these kind of things. Keeps you sharp.
Nice. Okay, so then just to make everybody aware of all the other user group meetings, if any of you, if this is your first time, we've got the ins and outs of data modeling. And Debbie, just to keep my memory up to date here, it's the first Monday of every month, and the next one is with Christian Carl, right?
Yes.
Okay, fantastic. And he's talking all about temporal data, I believe. So I believe that's the case, about time, travel, and what time is it now, right?
Correct.
Okay, fantastic. So then we have big data and data science. That's the one we're doing right now. We've got the data privacy, which was Carolyn Mouton and myself. Data governance and ethics, that's tomorrow. And Christine will be talking on performance measurement, and not so much performance management in terms of being a bad person and now we have to watch out what you're doing, but it's more about how do we set KPIs and goals. So for those people that are building operating models and plans and stuff like that, and you want to put in KPIs and measurements, it's now how do we get people to respond to that. So that's what Christine will be talking about tomorrow. We've then got the African data management community, which is going to be every Thursday of every week, and we'll be starting again next month. We haven't fully decided on what we're going to be talking about, but if anyone would like to recommend a knowledge area or an area that they'd like to talk on. I know we had a great session on career management yesterday. There's so much to talk about. I had so many people asking me for more advice, but we're open to any recommendations. All right. So the training for next month, and if you'd like to join, that's data governance, CDMP certification that Veronica will be doing, and data modeling, which is going to be done by Paul Krobler. Okay. So again, guys, if you'd like to join, we'd really love to have you. We'd love to engage a lot more. So give us a shout or contact Debbie if you'd like to. So today we are talking, Lourens is not going to be presenting, but he's going to be demoing batching versus queuing versus streaming. And it reminds me of the DMBOK Lambda architecture. I don't know how many of you guys have. I'm sure most of you have read the DMBOK, or I hope that you've read the DMBOK. And there's a Lambda architecture where it splits the data both into the batch processing and then also the streaming. And we've got Craig Botha here as well. Craig,
Hi,
how are you doing, sir?
All good, thanks.
Fantastic.
Good to be here for a change.
Great, excellent. Okay, so past events, these are the different areas that we've spoken about. And then just to notice and just to thank Lourens for his willingness to present. So it doesn't always have to be big PowerPoint presentations, it's demos as well. We're looking for presenters all the time. And if anyone would like to start a specialized knowledge area meetup, right? So we've got plenty of days in the month. If someone would, for example, would like to focus on data architecture or data value realization or ethics or whatever it is, please give us a shout and we can set one up and we can just help build a community of those areas, because sort of what we are finding is people like to focus on their area of interest. So then we do also talk about the CDMP sponsorship. We're still running that program. So if you've passed your CDMP certification and you paid for it yourself, Dama Saifka is offering a refund. And then we've also got some requests there in terms of if there's anything you'd like to do or talk on data management, you ask it, we'll prepare it, and then we can talk about it, and we can present it together. All right. So any questions on that before we go, and then I can hand over to Lourens. Anyone would like to ask about the events or anything happening within DAMA South Africa? Okay. Not okay. Lourens, all yours, sir.
Thank you. So yeah, I find it easier to write a few lines of code than I do to present a PowerPoint. So that's what I did. Hopefully this is entertaining and informative. And I'm not. Yeah, I'm not. Everything is just my own personal opinions based on my own personal experience. I chose this topic because I noticed a lot of people are throwing around terms that they have read about or they've heard in conversations or they attended a webinar, but very few people actually speak from experience of having done that which they talk about. So I'll show you what I do, what's a day in my life, and then the differences between specifically these three modes of processing data. When I was in high school, I had computer science. I'm not sure if people still do that in schools, but the only question was, are you going to have lots of small batches or fewer larger batches? But batching was the only thing there was, and then only later on came queuing, and streaming really only took off with the cloud. Before that, nobody had the hardware or the infrastructure to actually stream data at the speeds that we are used to now. But anyway, I'll share with you these. I'll take a screenshot of this and I'll show you what I have done. Also, I don't want this to be a monologue, so please engage. If you have any questions, just shout. I'm not going to see if you put your hand up, but I wouldn't mind if you interrupt me. So I'll show you what I'm about to show you. So I have, your data originates somewhere. So in my case, I just have a couple of files and I have a little script which uploads it. So however the data starts off its life, let's call this out of scope of this demo. I'm going to do this just from a shell script, just for the purpose of the demo. But in real life, your data originates in many different places. So the classic case of a batch handling, is like I'm going to upload data into a storage bucket. I'm using AWS simply because I'm comfortable with that. But I'm sure the other cloud providers have conceptually the same thing. So I might use AWS terminology, but you'll find a Google equivalent or an Azure equivalent. So I'm going to upload a batch, and then I have a program that runs on a Linux server. It looks at this bucket every 10 seconds. And if it finds any files there, it puts them into a database. So that's as simple as it gets, right? And then we'll speak about the pros and cons of each one. But let's start here. Let's start with this batching. And I'll show you. So my database, I love this movies. Yeah, if you know me, I use the movie lens data set. It's a public data set of all the movies that's ever been produced in the Western world, apart from Bollywood, because they produce more movies than anybody else together, But anyway, and then you have movie critics who give these things a rating, stars rating. So you'll notice the movie ID there, and then of course your ratings table. While this is just counting, it's counting the number of of ratings of these 58,000 movies. So this is it's this public data set. So it's very simple. It's just 2 tables, but it is so effective for, like they say, for education and development. So I'm using the full data set, which has 27 million movie ratings. So we'll see this now. There's 27 million of these, where people, just went and gave it a star rating. So then on average, you could take the average, which movie is the most popular movie in all of history, which we can do later. But so what I have done for the purpose of the demo, see, you have it's just IDs and the users are anonymous, and then you have a rating, which is the only thing we're interested in. So you can't get much simpler than this, because I don't want the data itself to complicate the demonstration. So I created different other tables. I created the batched ratings, which is empty at this point, and also queued and also streamed. And we'll populate these tables with the different mechanisms. So let me start here. So I'm here on a Linux server that's running on AWS. And if I go there, I'll show you this. I have these. I broke this up into 27 files of 1 million records each. I'm not going to do all of them. I'll just do the first one. So essentially, we can call this a batch of 1 million records, right? Do you follow me so far?
Yes, we do.
Cool.
I know I do. Yeah. Not sure about Paul, may be a bit behind, but
So I'm splitting my screen in 2 so that we can see things as they happen in, as close to real time as possible. Let's go to this side here. I have so there's my script. My script is only watching my bucket. So I'll do this. Let's run the script. We say watch bucket. You'll see that. So it's looking for files and it sleeps for 10 seconds, and then it looks at the bucket and sleeps for 10 seconds. Right. So now on this side here, I'm going to upload just one file into our bucket. Let's do that. Movie lens. So our bucket, I'm just going to upload one file there, S3 copy. I'm copying this first file to this thing, ratings. What are we doing? Batched. So you'll notice here's our buckets in AWS. If I go to the batch, there's nothing in it at this point. So when I upload this file, now what happens on the left here, our batch processor is still sleeping, right? So it has to finish its sleep before it wakes up. And then it goes, okay, there you go, found a file, found 1 million records, and inserting them into this database table. Which takes, I haven't optimized this for a reason. I don't want it to be too fast and then you blink and then it's all over, right? And also because I wrote this on Saturday night. So. You'll see now it takes some time. But so we uploaded one file. We can see the file in our bucket. If I refresh this quickly enough, there's the file, CSV file sitting in the bucket. So there we go. It's done in 48 seconds. And it deleted the file and it goes back to sleep. So this is your classic. If I refresh this, file is gone. And now if I look in my database, let's just do that. And there's our million records. So this is the classic batch processing, which is fine, you know, for some even production scenarios. You know, this is perfect. So do you guys, have you heard of the Zen of Python? I'm going to do this. You have to you import this. And it goes, simple is better than complex. These lines, complex is better than complicated. Flat is better than nested. But anyway, so it is, simple is better than complex. Right. Now the problem is your typical, let me just stop this here. So your typical manager always goes like, how do we make this faster? You know, we're the techies, we like to do things, but the managers always go, no, make it go faster. So there's two problems with this. The first problem is this thing has to finish its sleeping cycle before it pulls the bucket again, right? So if you look at this there, so there's every 10 seconds, you know, it could be more or it could be less, and then no matter if it's 60 seconds or if it's 1 second, you will always wonder, could I not make this more efficient? If it keeps checking the bucket every second, you know, there's a cost involved in it. And if this thing runs, you know, in the background for years and years, and you have to pay even just 1 microcent for every time it checks, you know, it all adds up. But if it sleeps for too long, you lose the latency, you know, or you pay the price in latency. So what we do, we introduce a queue. Now let me show you this. I'm going to show you what looks like the same thing essentially.
Lourens, just a quick question from Carl. He asked, do you have a link for the SQL workbench?
Oh yes, I do.
Is that the one that he's mentioned? www.sql-workbench.eu. Is that the?
Exactly. Yes. It's my favorite.
Okay.
Favorite tool. It can connect to anything that you can think of. So okay. Then so what I did then, I hooked this up. Now it's event driven. This is a different bucket. I'll show you now. This bucket sends an event to the queue, and then the event will wake up our processor from its sleep at any point when there is a new file there. So let's see this in action. And then I'll show you more. You know, you think, oh, you save some of the latency, but let's do this. So I switched to my queued, and where previously I had watch bucket, now I have watch queue, right? And again, I'm running my script. So now it's polling the queue, but polling might be the wrong word here.
Yeah.
Because it just wakes up only to write this log message out so that you know it didn't crash. That's the only reason for it waking up every 20 seconds or whatever, just to tell us that it's still alive. Now on this side, I'm going to upload my file again, but now I have a different bucket. Let's go here to our buckets. I have a different one called queued. And again, there's nothing in it. Now you might notice the timing of this. I'll show you. We'll upload this here. I want this thing to. So now it basically, I want it to just write this out and then go back to sleep immediately. Then I'll show you. So as soon as the next message comes out here, I'm gonna press enter on the other side. There, okay. So it's uploading its file. See, and this thing immediately wakes up. It doesn't have to finish its sleep. The event, it gets woken by the event that gets generated. So that's the most visible difference now when you do one at a time. Other than that, the process of inserting, it's exactly the same piece of code. So again, it's going to take about 48 seconds, I guess. But then we'll make it interesting when this is done. So we should see our file. There's our CSV file with 1 million. And so it deletes the message from the queue, the event. And then it also deletes the file. So the reason why it does this is so that it doesn't reprocess the same file again, you know, to prevent duplicates and things. So again, now if I refresh this, our file is gone. And if I query our table, which was empty just a minute ago, and now there's 1 million records. But now it gets interesting.
So sorry, Lourens, could I just ask
Yeah.
a question there?
Say again?
Could I just ask a question?
Of course.
That event mechanism, so you said that it sees it in that queue and it has to delete it so the event doesn't get re-raised.
Yes.
Is it? I'm assuming that is the program watching the folder, and when it sees a batch in there, then it raises the event. Is that the mechanism?
That is a good question, which I haven't explained in that level of detail. So thanks for that. So the queuing server, if you will, does that. So the program subscribes to the queue, and then the behind this, you know, it all seems serverless in the cloud, but there's a server somewhere, you know, managing this, and it generates the event, and it wakes up all the subscribers. So you could have multiple. You could have multiples of these,
Right.
basically listening or subscribing to the same queue.
Right. Now, in SQL Server, when you use the queue, it almost just has a status on there to say whether it's been published. So
yes, the event itself has a status. Yes,
right.
They say that this event has been almost taken by this processor, so that other processors can't take that same event.
All right. So is it then really necessary that you delete the file? Would it not just know that it's processed the event on that, or do you have to add more logic to stop it from doing that?
I just added it because now I'm done with the file, and the data now sits in the database, so there's no reason to leave it. But I also could have just left the file there in the bucket.
Okay.
What we normally do is we have a landing bucket where the data lands, and then you move it to the archive bucket for, you know, auditing and legal purposes and stuff. So here's what we do now. Yeah.
Lourens, sorry,
yes.
A question from my side. So you mentioned with the batch processing the cost of polling the bucket every however often there is obviously a cost associated with that. How does the cost then work with the queue? Because wouldn't there also be the same type of polling mechanism or similar type of polling mechanism which is used, or is there a slightly different mechanism that changes how the cost works? I'm assuming part of why we're doing this is to look at cost reduction.
Well, it's just different. It depends on your use case. So it might not, cost reduction is not the only consideration, but yes, it's different. So look, if I get one file in there, per hour, I pay only that fractional cost for that one single file. Where this one, if it checks it every 10 seconds, I would pay 360 times some fractional cost for it. So now it gets interesting. What if I want to make this go faster and I want to have 2 of these, right? So now I want 2 of these things. And I want both of them to listen to this bucket, right? There. So now let's see what happens here. So I'm going to stop my Q1. Go back to batched. You see, and now the difference is, because right now it seems that we've achieved only the same thing, except we added another component. But as far as the outcome goes, not much have changed, right? So now I want to split this in yet another one. Split this into top and the bottom. And now we have to keep up with all the things that happen at once here. I'm gonna go here to my same folder, batched, and I'm gonna start 2 of these. So I have there. This one is watching the bucket, and this one is also watching the bucket. And so now I have two batch processes. And in here, I'm going to upload 2 files. So let's do this. I'm going to upload $I. I'm going to put this in a loop to say for I in 1 and 2. So this is simple. I'm just going to upload 2 files as close to each other as I can. There. So there's a file 1 and a file 2. Now what happens? This thing happened to have woken up from its sleep, and it's processing. Oh, there. It's processing a file which is not there. Speaking of the gremlins, let's just stop this. My mind was in a different language at this point. I'll run it again, and I'll run this again. Oh, it put the file in there with a percentage sign instead of the number. Let's do this here. Sorry about this. That must be a $sign.
So one of the things we found with SQL was that, for example, if I ran a stored procedure that would sleep,
yes,
and it would wait on the queue and it would wake up. In terms of the situation, the user processes paid the price, whereas if I had a queuing mechanism, then the quality of service which restricted user processes wasn't affected. So they have those QoS differently, one being for a user process and one being for a system process. So it was cheaper for me to use queuing than it was for me to sleep and wake up and do the process.
Yes, exactly that. Yes.
So you get that cost benefit because you're not paying for the server process in the background.
Yes, because it charges you even for sleeping. Yes.
Yeah. Yeah.
So yeah, okay. Yeah. I'm uploading now. I'm uploading file 1 and file 2. Yeah. Now look what happens, because they both watch the bucket and they both take. Now this one is taking file number 1, and this one is also taking file number 1. Because all that they both do is they just watch the bucket and they take the first file that comes along.
Yeah.
So now I'm inserting duplicates into my database, right? Because both of these, and if you had like many of them in parallel in air quotes, because there's no parallelism here. So now if we had to make this efficient, you need some mechanism for these two processes to talk to each other.
Yeah.
To say like, look, this one should say, file number 1, I got this, so you take file number 2, you know, and just that inter-process communication. So that's what I have here. If you need any form of inter-process signaling, then you need significant code changes to the point where that code will overshadow the code of actually handling the data. Right? But let's do the same with the queue, and I'll show you. So now you see, now they both did file number 1, and now both of them are doing file number 2 also, because the one was, you know, and they do delete it after themselves, but the first one hasn't gotten. It was still reading the file, so it was still sitting there when the second one also started to read file number 2. Of course, whichever one deletes it first will then win, and the second one will try to delete it, and then that will fail. But now, let's show you. Let them just finish. I always feel bad for interrupting things when they're busy. Let them just finish their insert or whatnot. So while they just finish up, I'll show you this. So the other thing is traffic spikes. You know, if you have batches, how do you know? Like, how do you know how many files are still waiting there in our bucket? Or what if there's a spike in traffic and suddenly we get an influx of many files? So the batching mechanism itself doesn't have any metrics. So now you need yet another program to monitor that bucket, to say, you know, even if we were able to start multiples of these in parallel, you would need like a watchdog kind of program to watch it and then spin up more of these as the bucket grows in size, which again adds too much complexity. Let me show you now the queuing equivalent of this. So there, I'm just going to stop both of these, and we go to our queued one. So here I have my program that says watch my queue, and the same there. So both of them are watching the queue. Yeah, like I said, polling might be the wrong choice of word here, because it's not polling as it was polling the bucket.
Yeah, it's just actually waiting for an event. And then
waiting for something. Yes, exactly that. Yes. So now let's upload our 2 files to our queued one. So many silent vowels in the word queued, right? So I'm uploading 2 files, and then they immediately. Just a minute.
that was another event that your queuing has to look after.
Sorry, I had to mute. So what happened here? Our queue, the first one took file number 1, and then the queue itself marked that event as having been taken by this. You know, so all that's left in the queue is file number 2 for the other one. So just the fact that you're using a queue now makes it like it's not necessary to have any inter-process communication there, because the queue server handles that. If you know, so from there's no danger of duplicate processing, because the queue takes care of which events have been assigned to which of these processors. So that's where queuing, the big benefit of that. So let's see now. There's zero code change required, you know, and you could simply create more and more of these, and they would all just sleep until an event happens that has not been handled by all the others. You know. Does that make any sense? You follow me there? So do you see the benefit actually of having a queue as opposed to not having? And then queuing itself isn't limited to the cloud. You know, like RabbitMQ has been around forever. I think I first used RabbitMQ in like 2004, which is and it's still like the standard, you know, because it's been around for so long, and it's so stable and so mature. And you don't.
If you remember OS2,
Yes.
Their Windows events were used on a queue.
Yes, you're right.
And then before that, actually, IBM developed the MQ series, which changed the whole SNA protocol to be one from a synchronous communication to one to asynchronous communication.
That's it. When I went to RabbitMQ's homepage and I saw it still references like we started out as an IBM thing long ago under the hood.
Yeah.
Brilliant. So now what happens here? Let's say now you want these things to be as efficient as possible, right? But you don't want too many because you still pay for it, right? And for example here, now I have 2 of these on the same little server, but it only has 2 CPUs. You know, what if you could now have multiples of these across multiple servers, you know, multiple hardware, all listening to the same queue. But how do you determine beforehand how many is optimal? Like, you don't want too many of them just sleeping all the time, and you don't want the few ones that you do have being overloaded and falling behind. So there's a branch of mathematics that not many people know about, but it's called the queuing theory, and it's all, like I said, branch of math. It's been invented. So it's called an MMCQ, right? And I'll show you. So you can read up all about this. It's somewhat interesting, but not very practical. It's very theoretical. This is what the math looked like, right? Of to optimize this thing, right? And luckily, somebody made an online calculator for us there. So I'll share all of these things with you. So here's what we have. We have arrivals per minute. So it's made for like a a retail store. Really, it's where the whole thing started. Like, how many tools do you need open? the classic case of You don't want to wait in the queue too long, but you don't want all the people in the till to sit there and there's not that many customers. So arrivals per minute. I have a real world case that I want to share with you. So I have a spreadsheet with some data in it. There. So what we did, we needed to process 1 million files per month for a customer. And they come in at a rate of 23 per minute. So it's one file every 2 seconds or so, 2.5 seconds. That's the arrival rate. So I put the MMC value, lambda, 23 files per minute. But it takes 22 seconds to process one. So they come in at the rate of 23 per minute, but they only go out at the rate of 2.7 per minute. So how many do you need, right? So you use this, where is this browser? You use this to say we have 23 per minute and we can only service 2.7. Now you have to like iterate, almost like a little goal seek. Let's say we have 10 of these and we calculate, we press this calculate button. It goes, for if I had 10 processes servicing the same queue, they would run at 85% utilization. And you would have 11 files or 11 files in the system at any point, of which 3 would be waiting in the queue and the rest would be being processed by our 10 servers there. So all of this is where it gets practical, right? It means your latency would be 30 seconds. And you must have this. So let's say we want this thing to be more efficient even. Let's see can we get it to like 100%. So if we make it 9 instead of 10, let them be less idle. We get to 94% utilization. But now look, this latency actually changed from 30 seconds to 60 seconds. It almost doubled by just removing one of our servers. If we do 8, it goes now, our queue will never be depleted. The queue will tend to infinity. So 9 is the minimum that you can get away with. And then this directly has a cost impact because, on the cloud, for example, so we need 9 of these things and they charge this per hour. So it's going to cost us $44 US a month to process 1 million files. So you have to, when you talk about queuing, you have to do this math. You have to take this into consideration. Otherwise, you at least have to prove that your queue is not going to run into infinity. Plus, then you can calculate your latency, which is a good thing to know upfront. Right? Who knew this? Anybody? You're still there?
Yeah, we're still there. Yeah.
So if you had the same thing with a Lambda function, I'm not sure if you are familiar with Lambda in the context of the cloud. You essentially, it's serverless. So essentially, you have infinite parallelism because you can connect a Lambda function to your queue, and it would to your bucket. I mean, it would just spin up as many and run them all in parallel. So if you have 1,000 files all of a sudden arriving in a second, it would run 1,000 of these in parallel, just for that fraction of few seconds that it takes. But having that, the same thing would cost you $1,500 to process 1 million files, as opposed to $44 if you use only 9 Linux instances. So again, it's so easy to fall for this trap if you're not aware that this branch of mathematics even exists. Right?
So can I ask you, Lourens, in terms of, is it not possible to run multiple threads? Why do you need to run multiple servers? Why can't you use multi-thread?
Oh, yes, yeah. So what we've done, I'll show you something interesting. What we've done for one of our customers now, we use Spark. Okay, so Spark, it runs multiple threads on as many threads as you have CPUs.
Right, yeah.
So if my server has 2 CPUs, it will run in 2 threads, and it would literally read, when it reads this file, it would split it in half, and each thread it would go, okay, you take the first half and you take the second half, which is brilliant. So we've done that, and then we've also calculated, after processing each file, we do that calculation to see how many do we need now. Are we still okay? Do we need more of these or not? And then programmatically, you can spin up more instances or spin them down. So it's called an auto scaling group. So what we did here, on the left here, you'll see this is our queue size. So if you have a spike in traffic, and the queue, now there's 200 files or there's 300 files in the queue, it would spin up more of these instances here. It starts at like 5 or 6, it goes up to 10. At this point, it started up 40 different servers. And then suddenly the queue drops, whoops, because all 40 of them, they handle this. So when the queue size drops back to 0, your active instances spin down till there's only the bare minimum left. And we do this quite efficiently. So now we can take this queue up to 300,000 files, sitting there in the bucket, waiting in the queue, and it would spin up as many as needed to handle all 300,000 files, and then spin them back down again. Works quite well.
Nice.
Yes. And then, okay, so I have just a few minutes left. I want to show you just the streaming part of it, which is, again, it's a whole different ball game there. So let's stop this. And I'm going to streamed. So I stream, I can close this one. Let me just exit it like that instead there. So for streaming, I have a simulator. I have my files are in, my data sits in files now. So I have a simulator that kind of just streams, some as many records as I want. So I just run this thing, real-time simulator. I tell it inject 5,000 files into the stream for 10 seconds, Before I press enter there, I'll show you something. So now streaming, the data is in flight all the time. It's never at rest, right? So we have a stream, and now I'm going to do some real-time analytics on this data as it is in flight without it ever like touching a disk. It's just on the network, in the form of a notebook. So if I go here, what happens here, this is also just to show you that not all notebooks are Jupyter notebooks, and not all notebooks have only Python. So there's a thing called Zeppelin, and this Zeppelin, it uses Apache Flink, and it's essentially SQL that I'm writing. So I'm creating a table that, but it's almost like a virtual table. It's a table with my stream data flowing through it. And then I can run SQL live on the stream as it flows through my notebook. So if I start this, I want to say, show me just the average rating of these movies. Right? So now this thing is starting, but the stream is empty. If I now start simulating real-time ratings into my stream.
And can I just confirm there, Lourens, that's individual ratings. They're not sort of batches of a million ratings. They're actual individual ratings.
Exactly. Yes. So now it's individual records.
Right.
And here I'm running live analytics on my real-time stream as it happens. Of course, all the data in flight has to come to rest at some point, right? So what I have here is the same stream. I'm injecting this into two different streams. So this stream, it accumulates it in memory, and then every 5 megabyte or 3 minutes, whichever happens first, it just writes that into a file. It just dumps it into a file. For example, now there are so many things you can do with streaming. But if I go to my bucket, I can go to streamed, and there is my data. So it goes, what's the time now? So we'll find it there, and it just creates these files, which is just the dump of the data, and it accumulates that there's a timeout or a size timeout, if you will. So one of the things that is noteworthy is that if your data sits in a file anyway, it makes no sense to turn it back into a stream. There's no benefit to that. The data is already in flight. So because you already lost the real-time nature of the data, but all the data in flight becomes data at rest at some point. So it goes one way, but what I've done is to take my file and inject the records one by one into the stream just for this demo. But in reality, if your data is in flight, think of like a factory, where you have millions of sensors. That's why the data keeps on flying. The signals and events keep on flying all over the place. So again, streaming, you don't need a cloud for it. There's so many. There's these different implementations, and they all have their pros and cons. Interestingly, though, they're all Apache by the Apache Software Foundation. And most of the IoT, Internet of Things, most devices implement this MQTT protocol. And that's why there's so many, because they all can, as long as they all speak the same language, everything's interoperable. Just one thing to note is this MQTT, the letter Q there is misleading. It is a stream, it's not a queue. It's a stream of data. So when streaming, the payload is the actual data record. Whereas with queues, in a queue, the payload of that event, it's only the location of the file, it's not the content of the file. So those are the differences. And then I can show you some, of these. You can connect from and to so many different things. I'm just scrolling here to where it says sources there. So These are all the different things that it can connect from. Doesn't show it very well. Let's go to something else. You can connect to. It can take data or records from. You can have a Twitter stream, and do like live analytics on Twitter, tweets as it happens, all that kind of stuff. Log files is a big one. So each log file, when people log in or whatever, you can use it for security, to preemptively detect hackers and stuff. And then the sync is where the data goes afterwards. And as long as they all speak the same MQTT protocol, you can daisy chain all of these things together in any way you like. But that's all I wanted to show you is this basically real-time analytics on data in flight as it moves, using a notebook, a Zeppelin notebook, using Flink, which is a dialect of SQL.
Okay. Thank you.
And all of these things have their pros and cons. It all depends on your use case, but simple is better than complex. Always. If you remember one thing, remember that. Simple is better than complex.
Excellent. Thanks, Lourens. Thanks very much for the demo. Any questions? Zuletu, I see that's something you've been looking for. Is that your application? Is there a process that you're using?
On my side, we are busy with the project at work, and we needed to be able to make a decision regarding polling or using triggers or streaming. So it's something that made my life much easier now that I know which one is the best, and I've been advocating for triggers as opposed to streaming. Sorry, as opposed to polling, because polling can be expensive on resources.
Yeah. Fantastic. Lourens, could you put your email address in the chat box, and if you'd like to contact you, would you be comfortable with that?
Yes, I'd love to talk shop at any time. I'll clear my calendar and spend my weekend, talking shop about these things. So
hopefully we'll be able to get some of the artifacts that you have, Lourens, here.
Yes, I will send you my mind map and my little diagram. It's not much, but yes.
Yeah, I actually like your mind map. I kind of think along those lines as well.
Cool. Yeah, there's more. I didn't mention anything that's in there, so maybe I'll just send it to you.
All right.
For future, for reference later.
Thank you very much, Lourens.
Lourens, if you wouldn't mind just putting that into a PDF so we can share it with everybody as well.
Absolutely. Yes.
All right.
Yeah.
Thank you.
Any other questions? Anybody else? Fantastic. Lourens, thank you very much, sir. Really appreciate it.
Thank you.
Thanks for your time and your preparation.
Yeah, thank you for the opportunity. Anytime.
Excellent. Fantastic. Thanks, guys.
Thank you. Cheers. Bye.
Thanks all. That was great. Thank you.
Cool. Thanks everybody for your time and attention.
Thank you.
Thanks,
Bye.
man. Cheers, everybody.